what is the domain of this function f of x is equal to the square root of x minus 2 over x minus 3. Now, the domain is actually the list or the list of possible values of x. Okay, and most of the time domains are all x can be all real numbers. However, we understand that there could be cases wherein x cannot be something because of our restriction. For example, in this case, the very common restriction is that the denominator cannot be 0, right? You are not allowed to have a 0 denominator in a function. So x minus 3 could not be equal to 0, and surely x must not be equal to 3. Okay, this is one of the restriction, meaning x can be any real number except for this one, but it's not that all yet. I mean, it's not the end of the restriction because we have a square root thing. Having a square root simply means that we cannot have what? We cannot have a negative number inside the square root in our argument, because we are supposed to only have here domain in among real numbers only. So which means that gives us x minus 2 over x minus 3 must be greater than or equal to 0. And now we are having this inequality here, and we're looking for the possible solution set. Now, for this, actually, the best thing to do here is somehow find first all the critical points. What are those critical points, by the way? Those are the values that will make either the denominator 0, which is in this case 3, and also could make the numerator 0, could be 2. Meaning, these are the critical points. What do I mean by that? This critical points will somehow divide our real number line into 3 segments. Okay, this will divide the real number line into 3 segments. Okay, this is here, there's a 2, there's a 3, and this divides the segments into this one. As you can see, we cannot have a closed bracket here in the 3 because x cannot be equal to 3 because it's in the denominator. So let's have that. That's one of the segment, one of the interval here, from here to here, and from here going to the left. Okay, so this is to the negative infinity, this is to the positive infinity. So we have a real number line broken down into 3 intervals. And what are those? Let me have it here. Intervals. In an interval form, it could be written as negative infinity to 3. We will use, to 2, negative infinity to 2. We could use a closed bracket because there's an equal, greater than or equal sign here, except for the 3 because it's the denominator. Okay, so it must be a square bracket here, and then we also have the other interval. Square bracket 2 to 3, which is an open bracket, and lastly our interval will be there's a 3, open bracket 3, open brace, and we have a positive infinity there. Okay, and how do we check which among this interval fits? The idea is you can have like test points. Okay, you can create some test points, any representative for this interval, perhaps a 0, right? Because 0 belongs to this interval. Here you could have like a 2.5. Okay, 2.5 belongs to this interval. Here, any numbers between 3 to infinity, you can have a 4, and then you check and you conclude if that generates a greater than or equal to 0. If x is 0, what will happen? If x is 0, check here, negative 2 divide negative 3, it's a positive number. Is it greater than 0? Yes. And the conclusion here is just a yes or a no. So it's a yes, meaning, oh, this interval belongs to the domain. How about this 2.5? 2.5 minus 2, it's a positive. 2.5 minus 3 is negative because 2.5 is smaller than 3. This gives you a negative number which is not greater than 0, which is no. How about if it's a 4? The answer is yes, right? Because 4 minus 2 is a positive 2 divided by 1. that's greater than 0. So it's a yes. So meaning our domain now will be the union of these two. We sum up that 2, and therefore here domain will just be equal to negative infinity to 2 close union of, we start with 3. Note that the 3 will have an open brace, not a square bracket, plus infinity. So this is our domain. Okay?